Hello, ladies and gentlemen. I am Hadi Esmailnejad from Sand University of Technology, Iran, and my talk is about connection orientation calculation in single-layer lattice space structures using Formex Algebra. Given the great potential in Formex Algebra and high performance of new version of its programming language, this software can be used well in other related areas in the field of computer-aided structural design, from design to fabrication. One of the most important issues in the design and construction of the lattice space structures, especially in the freeforms, is the calculation of connection angles with corresponding elements. The present work attempts to develop a new tool for the calculation of connection angles using Formex Algebra and possibility of creating supplements in Formian-K software. As you know, one of the most important approaches to perform the configuration processing is the use of Formex Algebra and parametric formulation of the structural forms. This figure shows a Formex and its components. On the other hand, matrices, due to their history of origin and development, have been reduced in programming languages. According to the new subscripting system, matrices can be easily adapted to FORMICES in Formian-K software, where each counter like Fi from Formex F can be a 2D matrix. But in any case, using FORMICES for programming purpose has its pros and cons. The ability of FORMICES to generate and process discrete structural forms is one of the most important advantages of using them. The connection orientation can be defined using connection angles. The angles U and V are the horizontal and vertical connecting angles. The angle W is the rotational or twist angle of the members that defines orientation of the cross section at the connections. As you can see, it is easy to calculate the axis vectors of the members and obtain the panel vectors by cross product these vectors. Then nodal and member vectors are calculated with averaging technique according to formula. To calculate the connection angles, it is easy to use some of the concepts of Formex algebra. For example, the vector projection process can be easily performed using the projects function. Using Formex algebra, a new user-defined function called GONIOMETER is implemented in Formian-K software, which is able to extract information about connection angles, member vectors, node vectors, and etc. Where the GONIOMETER function finds the requested angle or vectors from Formex F and places them in Formex E. The first and main canonic parameter output is the angle or information requested by the user, selected from the numbers 0 to 10 according to the table. This figure shows the result of GONIOMETER function for a space structure configuration in which, in addition to configuration, the node vectors and the member vectors are also plotted. As you can see, with the new developments in programming language for Formex algebra, structural configuration processing field can be well related to other fields. For example, connection angles evaluated in a diamatic dome using goniometer supplement. This figure shows the studied diamatic dome with node vectors, which is generated using goniometer supplement in Formian-K software, and this table also provides information on the range of variation of angles in this dome. This table shows the formices of connection angles in nodes 78 and 79, as node 79 is selected on the main meridian and node 78 is selected on the triangular network adjacent to it. This table shows the connection angles for previous nodes in detail. Comparing these tables can have interesting results. Also, the results of GONIO supplement have been validated using AutoCAD software. Conclusions. From this study, the following conclusions or points can be noted. 1. Using Formex Algebra, the connection orientations can be easily calculated. 2. The goniometer supplement is able to automatically and accurately calculate the connection angles. 3. This new supplement provides a practical tool that can be used to optimization, analysis, manufacturing of jointing systems, CNC machining, and 3D printing, 3D structural modeling for manufacturing, and etc. As seen in this figure, using the potentials of Formex Algebra and the development of such supplements, users can be enabled to create three-dimensional structural models and guides them from conceptual or wire models to fabricational or constructional 3D models in Formian software. So I think this could be an answer for the future of using Formian in the design activities of architects and engineers. Thank you for your attention.